Hello, good morning. My name is M. Sheshagiri. This is Electrical Machines 1 lab. And in this laboratory, the third experiment is load test conducted on DC series generator. So for that, let us see why this test is required to conduct on DC series generator. To know the efficiency of the series generator, it is essential to connect that power supply generated by the series generator on a variable load, and every load we need to take the readings of terminal voltage and the current drawn by the generator with the variable loads. So after taking this, we can know output power generator and efficiency of the generator. So these are the essential parameters we can know by conducting this experiment. So before going to conduct the experiment, let us see the name board specifications of the motor and generator. So every DC generator, there will be a prime mover which is DC series motor and mechanically coupled to the DC series generator. For this, let us see the name board parameters, specifications of the name board. So one side it is given for the motor specification, the other side is generator specification. In this motor, the rating of the motor is 5 HP, speed of the motor 1500 revolutions per minute, voltage is 220 volts DC, current capacity of this motor is 20 amperes. When coming to generator, type of the generator is series connected, rating of the generator is 3.5 kilowatts. So everywhere, for note down this point, motors are specified into horsepower 5 HP and generators are specified into kilowatts, 3.5 kilowatts. So speed of the generator is 1500 RPM, revolutions per minute. Voltage of the induced voltage in the generator is 220 volts and the load capacity current is 16 amperes. The load which is given on the generator, it should not exceed more than 16 amperes. These are the essential specifications of the machines. Everyone should know to operate the machines under these specifications. So now let us see the circuit diagram, so which is displayed on the screen. So try to know the terminals on the panel board. So here I will explain. It is a DC series motor generator set. So motor is mechanically coupled to the DC series generator. So this section belongs to motor terminals and this section belongs to generator terminals. So generally a series motor consisting of armature terminals as A and AA, series field winding terminals of Y and YY, noted with Y and YY. Generally series field represented with a thick wire of less number of turns, whereas shunt field is represented with more number of turns and lengthy wire. That is the difference between shunt field and series field. Generally we should represent the series field while drawing the circuit diagram. The turns will be less and thick wire, and thick wire less turns. So this is the motor, these are the motor terminals and these are the generator terminals. Let us understand how to connect the circuit diagram. So these two are the power supplies. Switch off position, only this supply is for only display of these meters. Only phase terminal is given to this. This is not DC supply. When it is switched on and this is pressed up, now DC supply is connected to these two terminals. So I put it in off situation and I'll try to explain the terminals. These three are the main 2-point starter terminals. A DC motor is operated by making use of 2-point starter, and the 2 points are nothing but L and A. Since it is a generator set, we have a neutral terminal of L minus also. L minus is connected to negative of the power supply and line is connected to line. This series field is in series with armature. So first A terminal is taken to ammeter, ammeter other terminal is taken to Y terminal, YY is connected in series with armature and AA is taken to negative. A voltmeter is connected parallelly with the power supply. That is about the motor connection. So you can verify the connections procedure by verifying the circuit diagram here. Let us come to the generator. Generally, generator will induce the voltage. Terminals connections in this series field is connected in series with armature. So Y is connected to A. YY is connected to A. Remaining two terminals Y and AA, Y is taken to voltmeter and ammeter. Ammeter other terminal is taken to positive of the load. Negative of the load is connected to voltmeter second terminal and that is connected to AA. That is the generator connections. So now let us see with the help of Madhu sir how to connect the circuit diagram. Now first terminal is positive is connected to L of the starter. Positive terminal is connected to L of the starter. Starter is having two terminals. Since it is a 2-point starter, series motor is always operated by means of a 2-point starter. And next coming to voltmeter is connected to L. Then next A is connected to an ammeter. We are placing one ammeter between the starter to armature terminals. A is connected to ammeter positive. Let us select 20 amperes range, 20 amperes range of the DC ammeter, and that is connected to Y. Now YY is connected to A. Series field is connected in series with armature. YY is connected to A. Next, AA is connected to voltmeter second end. AA is connected to 300 range of voltmeter is selected. AA is connected to voltmeter second end and that voltmeter second end again connected to negative, power supply negative. And from negative of the power supply, starter negative terminal, L negative is connected. If you avoid this connection, the starter will not hold the handle. So that is why we are connecting L minus to negative. Now coming to generator section. So generator section, Y is connected to A initially, YY is connected to A. Now this Y terminal is connected to ammeter. Y is taken to ammeter positive and voltmeter positive, both ammeter positive and voltmeter positive. And from here you connect to ammeter. Ammeter negative is taken to this load positive. We have two terminals for the load. Ammeter negative 20 amperes range to be selected.
Positive, which is negative.
Ammeter negative is connected to positive of the load. Load negative is connected to AA. Load negative is connected to this AA. And one more connection left, that is voltmeter negative, that is 300 volts is connected to AA. All connections should be tight. So now the circuit is connected, L to L, A to ammeter, and again one more terminal A is taken to voltmeter, ammeter next terminal is taken to Y, YY to A, and AA is connected to voltmeter negative and power supply negative. This starter negative is taken to negative of the power supply. Generator terminals also generally we know series field is in series with armature. So and Y is taken to ammeter and voltmeter commonly, and next terminal of the ammeter is taken to load. Load other terminal is closed here and voltmeter also closed here. Generally meters are to be in sleepy position, but for the convenience I would like to explain in this video by making it stand, because one should watch the reading. So for that I am making the meter to stand for explanation. So now let us start the motor. Since one thing students should remember, that since it is a series motor generator set, the starting torque of the series motor is high. It should not be operated without load. So initially we should operate this particular series motor by applying the load on the generator. So now the load is zero position. So I'll switch on some loads. A DC generator never be started without load. That is only the precaution we need to take. If the load is off position, zero position, if you switch on the equipment, it will rotate in highest speed. That is danger for the motor. It will damage itself with its own speed. So that's the reason I switched on the load. Now Let us switch on this power supply, operate the starter. Now the motor is rotating at 1435. Let us decrease one load. Let us decrease one load to adjust the speed to rated speed. So now it is rotating at rated speed 1500. Now this meter is showing and voltmeter is showing 220. Now ammeter is reading. This is the current drawn by the motor and this is the voltage given to input, and these two meters are connected to generator. This voltage showing how much voltage generated by the generator and what is the load we have connected on the generator, that is shown by this current. Now gradually vary the loads on the generator. This terminal voltage is decreasing and the current drawn by the generator electrical load is increasing. Like that we vary different loads and note down the terminal voltage and current. For 5 to 6 readings beyond the limit of that current rating, load current rating, that is 16 amperes. That is the procedure of this experiment. After taking the readings from terminal voltage and current, ammeters and voltmeters, we will calculate the efficiency, output power, input power, and the ratio between output power to input power will give the efficiency of the DC series generator.